Right, it's a pleasure to be here. I've been told to stand on stage, but I really want to start a conversation to those who are in the manufacturing space, particularly who have a special knowledge of Industry 4.0. Anybody in the room here with that knowledge? Anybody with experience in manufacturing? Who services manufacturing clients? A few hands, okay. Just a few words on me before I start out. We're one of the startups that were just mentioned. Authentise, about 12 people in Salt Lake City and here at the NASA Ames campus. We work in 3D printing software, specifically process automation for 3D printing. I can talk more about that at another time. But I'm also a faculty member of Singularity University, which is also based here in the area at NASA Ames, and deals with exponential technology trends. And my specific area of expertise there is digital manufacturing. So that's my background. And so if you have any questions on those two, we can talk about this later. Now, typically, I give a 3D printing talk, because that's what I do. And I've been told I'm not allowed to give that today, but I thought I'd throw a few slides up anyway. So just to give you some context where digital manufacturing is heading or has headed, this is the fuel injection nozzle from the GE's new LEAP engine. Has anybody seen this before? No? Okay, great. Well, this is wholly 3D printed in titanium and ceramic. They're printing 3,500 of these annually, reducing the weight of this part by 25%, durability by 5-fold, and reducing the part count of this part from 21 to 1 parts. So just in case all of you thought of 3D printing as printing trinkets for toys, that's not where the industry is anymore, right? About a third of all components that are printed in 3D printing are now industrial end-use parts, right? That are incredibly high performance, used in Formula One, oil and gas, aviation. GE has committed $4 billion from 2010 to 15 to get this process up and running. They have multiple factories ordering hundreds of machines, just 3D printing components. So that's where the industry is, but apparently I'm not allowed to give a 3D printing talk, so I'm going to move on. So instead, we're going to talk about Industry 4.0, which really is an extension to me, of additive manufacturing, right, of 3D printing additive manufacturing. Industry 4.0 is a $720 billion market just for equipment sales, when 3D printing is only a $5 billion market. So for me, 3D printing is a subset of the of the Industry 4.0 market. And to be able to mention it as such, I have to define what it is. So a lot of my talk is about what is Industry 4.0, because it seems like one of those keywords that's being thrown around a lot, especially after Davos. And what is happening after Davos is that a lot of people are talking about Industry 4.0 as an industrial Internet of Things play, that it's all about getting data out of machines. And so for the rest of this talk, I'm going to be arguing against that. And saying that we've lost our way in what Industry 4.0 is and what the bigger opportunity is. And for all of those servicing clients, whether it's an IT, manufacturing, services, workforce, this change is going to affect you in some way. And I hope at the end of the talk to be able to give you a sense for how it's going to affect you and what opportunities you have as a result of it. If you don't give me a timer out here, I'm going to forget and run away with time. So thank you. So what's Industry 4.0 today to those people that are talking about it? It's really all about data. That's what they're concerned about. Although the promise was a little bigger to start off with. It's called 4.0 because they're putting it into a trend with Henry Ford, the steam engine. They're really thinking grand schemes, right? And they're really going down Mark Andreessen's route and saying, OK, software is eating the world. And then they're like, oh, it hasn't eaten manufacturing yet. So manufacturing must be next, right? That's what they're thinking. And it makes sense, because in a lot of respects, the technology that we're using at the shop floor level is really ancient. A lot of people are using XP. A lot of people are using floppy drives. I lived in Nigeria for 5 years, and we were using machines from 1901. Right? So a lot of old equipment being used on shop floors. But the promise of changing that is one that's initially tied just to production efficiencies, energy efficiencies, being able to reduce downtime. So really keywords that get anybody who's in the manufacturing industry today really excited about the promise. Now, the first hurdle that people ran into when they started thinking about this opportunity, OK, let's network the machines, get data out of them so that we can predict when they're going to go down. That was the first thought. Then they're like, oh, we can't get the data. because a lot of these machines are built in walled gardens, which means that the OEM hasn't allowed kind of an open standard to receive any data out of. Right now, experts estimate that only 5% of the data that could be available is actually becoming available from the shop floor. So right from the beginning, there was this promise, and then there was a reality check. It's like, oh, we can't do this. So a lot of the work that we're doing right now is actually getting the data, cleaning the data up, because we realized, well, it's not quite as clean the data as if we had designed an entire system from scratch, right? Like Facebook gets a lot of data. There's a lot more data in manufacturing, but the data that we can get out of Facebook is clean right from the start. We know what it means. We don't have to parse it. It's very simple to understand what that data means. In manufacturing, we don't have that opportunity. So, so there were these barriers that have been hit, and that's really what's oriented the industry right now. And the understanding that we're at presently is how can we get the data out of the machines? How can we clean it out? What are the protocols that we can use to get actual value out of the process, out of the manufacturing process that we didn't get before? But to me, that's missing the point, because the promise started out as one that is much greater than that. The promise started out as, we're going to change manufacturing as a whole. We're not just going to make it marginally more efficient, right? And that was, and that's actually what the larger organizations, thank you very much, the larger organizations like Microsoft, GE are looking towards now. How do we not just improve efficiencies? How do we actually go about changing the economics, changing the business model in manufacturing? And so that's the next part of my talk. And I really want to talk about here is the promise of agility, of going and saying, how can we, in a world that's filled with immediacy, in a world that's filled with Snapchat and Facebook and information flow overload, how can we make the companies that provide the physical products in this digital world as fast as those who provide the digital products? How can we make them as agile as that? That really is, to me, the underlying promise of Industry 4.0. Not that we're improving marginal efficiencies in the manufacturing ecosystem. No, we're changing the way it's run to make it more adaptable, to make it more like what we're seeing in the rest of the world. And this is being pushed from all angles. The agility, the need for agility is clear, not just in reacting to consumer demands. It's also clear in reacting to spot prices in fuel, for example, right? You want, as if your gas price goes lower than your oil price, you want to be able to switch to gas instead of oil, for example. It's the ability to react to the competitive pressures that I'm getting every day, and that's one example that I want to speak about, just one of those deep dives, right? Because we've got this incredible trend in aviation. The pressure to improve the fuel efficiency has been very clear right from the beginning. In automotive, it's the same. How can I improve the power-to-weight ratio in my cars? Very straightforward, very clear where it's going to be in 10 years' time. And then you come along and say, how about I'm going to make a car that has half the power double the power-to-weight ratio of the Bugatti Veyron? Just like that. That doesn't fit on any curve. Right? That doesn't go and say, OK, I have improved by X%, which was what we did last year, so therefore I must be good. No, these guys came along and completely changed the manufacturing game because they put 3D printing at the core of it. This is a 3D printing example, reducing the tooling cost for this car, as well as improving the performance ratios. Right? So now we're changing the paradigm in which we're acting, in which we have to react to certain to market pressures and to competition. Whoever gets a chance to ride in this car, I really recommend it. It's amazing. £1,400 for a car with a sports engine. Unfortunately, I drove it down. I think it was University Ave, so we had to stop at every light. But not really a racetrack, I can tell you. But this is an example of the way that manufacturers can't just build new car plants that are building the same car for the next 10 years. We need to be aware of the fact that our competition is actually moving from all different angles and be able to react to that. So what these guys are now doing, the company is called Divergent 3D, they're actually selling the system of manufacture to car manufacturers in general. Right? This is their their move. This is just an example play. So the question is, if agility is what we need, not just marginal improvements, how do we get that agility? Right? And that's where a lot of our thinking has been in our startup and our actions. Right? So the basic premise is that Industry 4.0 today is being thought of as gathering data from the manufacturing devices on the shop floor. And that's great. That creates insight. But the real agility, the real value is created if you turn that insight into action. If you go and you're able to affect the input into the machine, very simply put, right? But that input into the machine is just the same as it was in the 1970s and 80s. We're still writing our CAM systems the same way that we did back then. So CAM, controlling our devices the same way. We're selling $720 billion of machines a year that understand software code, right? $720 billion worth of digitally enhanced manufacturing equipment. And yet, we have them placed around the shop floor like ivory towers that can't understand, won't understand commands we issue centrally. Right? The best we can do right now, and I told you it's only 5% cases, is capture the data that comes from the device. If we really want to improve, really want to act, really want to be agile, then we need to be able to switch and say we're going to push data into the device. And that means changing the way we see our data. Our digital thread is a keyword that people talk about a lot, from the design to manufacture process, which is just as long as it was back in the 80s, as I mentioned. So this is this is specifically for additive manufacturing, the different processes that you might go through to get a part into the production device and beyond. So what the initiative now is if you want to take an insight and turn it into action, you need to turn these 30 or so modules into 5 to be able to directly affect the manufacturing device. And not only that, but also create an enhanced digital loop, not just a controlled environment within the manufacturing device, but one that goes and says, I'm going to affect from the learning that if my machine fails, I will affect the way it's been set up. I will affect the design. I will take that feedback from the manufacturing device and feed it all the way back into the raw input that I was getting. And vice versa, different parts along this process. This is not a single directional data flow. This is a data flow that goes back and forth and has a conversation about it. And the reason I know that this is happening is that individual building blocks of this environment are already starting to occur, right? So, for example, I'm going to mention a few exponential trends that are really converging on providing the ecosystems that we need. One of them is the Google Tango. Who has heard of the Google Tango? Anybody? Yeah. So, digital sensing, 3D sensing in our phones coming out this year. In 1 year, we're going to be creating more 3D models than in the 10 previous years combined. But what that tells me is not that we can create 3D models, is that sensing has become incredibly cheap and incredibly accessible, right? So suddenly I've got sensing. And then with those sensors, I can design. I'm not designing anymore the way I used to in CAD. I'm not having somebody sit there and design a part and the outline. I'm taking my constraints, in this case, a motorbike, and I'm saying I want 2 wheels, a seat, and a handlebar. And then the computer goes off and designs the part. This was in 2011, so this is quite old. And what they're doing is just inspiring the designer along what's called Wolff's Law. What is the optimal way that nature would distribute the weight or the material in order to be able to achieve that particular objective. Right? So I can take my sensing and design automatically out of that. Right now, they're just informing the designer. The designer goes off and designs the final motorbike. But I can go and design the motorbike and impact and build it. And not only that, but I can go and say, OK, based on my constraints, I want to have different material properties from the same feedstock that I used to have. This is one example that they call architected materials, where we're not changing the underlying material. We're changing the microstructure of that material to be able to react differently. And a good example is at Lawrence Livermore, they were working with elastic, that if you pulled it, it didn't contract, it actually expanded, right? Or a block of material, if you heated one side of it, the other side got hot, but the side that you were heating wasn't getting hot. That's what you can do with material structures, and that trend just continues And then you take that material and you're making it in a machine that isn't single purpose anymore. This is a hybrid machine that actually has additive and subtractive tools in the same tool set. For me, this is kind of the definition of a factory in a box, right? So you have a situation. A good example is in Nigeria, I was investing in companies, and one of the companies we were looking at was a company that made the scratch cards for mobile phones. And the company that made 170 million people, scratch cards for half the country, was located in a garage behind an apartment block, right? And I'm like, now I realize what I saw there was the future of manufacturing. We're not if we can have intelligent manufacturing devices that have all the different manufacturing tool sets available within the same device, I don't need a huge factory floor anymore that can make anything. Make something in sequence. I can have it all in a single machine and have it made on a much smaller footprint, right? So these four trends are converging in a way that I can take my sensing input, I can use that sensing input, let's say a part breaks. I have a sensor and it tells me that a part is broken. I take that information, I feed it right back into my design loop and I say, okay, my part is broken, now I have to re-engineer based on the constraints I had previously issued a part that it takes that break into account. Right? And then I take that information and I feed it into, okay, what materials do I now need to produce to be able to make that part, that component? And then I go and I make that component in a manufacturing device that doesn't require an entirely new hard tooling software chain. My point here is that process is going to take 2 seconds instead of 2 years in the future. From recognition that something needs to change to actual new sales process, I can actually, the moment I recognize it, I can redesign it. I can redesign it and impact the parts that are already being built in my machine. That's the future of the digital thread. That's the possibility that Industry 4.0 gives us, and that is a technology that already exists today. So what we're doing at Authentise is just flicking those pieces of technology together, right? So what does this mean for you? And really, this is as far as my thought process goes. So I'd love for you guys to help collaborate. But where does this go for you? It means that business models are changing. First of all, fundamentally, the World Economic Forum realized business models are substantially going to change. And they're already doing so. I mean, Caterpillar is selling its trucks not by a fixed price, but by metric ton moved. Kenmark is selling their tooling equipment based on holes drilled. GE is selling its engines based on hours flown. Right? So we've got this output-based economy that's rapidly growing because we have a much greater awareness of the data around us and how these devices are performing. The next step after that, and this is something, it's my favorite topic, so please come and talk to me about it, and it's part of my 3D printing talk, so I snuck it in here again. Is the autonomous on-demand, localized, distributed manufacturing, right? And so business models change. But that means, and if business models change, it naturally means that every part of your organization or your client's organization has to change, right? If I want to collect constraints instead of just design, because constraints are now important, the actual design is just computer generated, then I need to go along and I need to change the way I'm capturing that data. Right? That is both a workforce problem and an IT problem. Right? I'm going and I'm creating the insight from the manufacturing devices, but I'm also pushing data in. I'm not just building the data capturing devices. Your IT is going to change. And if I move towards that distributed manufacturing vertical where manufacturer isn't actually responsible for the production of a part anymore, but I have thousands of smaller manufacturing outfits that are doing that for me, then the nature of a manufacturer changes, and I need to start offering value-added services the same way the music industry has had to change from selling CDs to selling concert tickets, right? And the only way to really understand how this process is going to go and how it affects you is to start experimenting. So at Singularity University, we have dozens of major corporate partners like Bayer, like Coca-Cola, like Lowe's, that work with us to build a small part of that future. And even if it loses money, it still gains experience, and it still makes everybody in your organization and the stakeholders around it aware of the changes that are about to occur, right? So the best way to build the future, best way to experience the future is to build it. And that's why, coming back to what Authentise does, we started merging this for a very small part of the manufacturing ecosystem with 3D printing, merging the tool chains now, because we realized that that was the future. That's where it had to go. If distributed manufacturing is where we think the supply chains are heading, then we need to start merging these components to be able to be more agile in remote locations. So that's where we are now, and we're working with partners like GE and Caterpillar, Lego, Lowe's, Lego and Nike and Ricoh to make these changes happen, again, for a very small part of the digital manufacturing ecosystem. But I'll leave you with this, which is a graphite aerogel. This is the latest news. They've figured out how to 3D print this. This is lighter than air. This can take twice its weight in fluid and compacts into compacts 90% of its size. It's just my last little bit about 3D printing that I wasn't allowed to talk about today. So thank you very much for your time. Appreciate it.